So this next step after dam 2 is basically we're going to configure the mesh for fluid. We're going to turn off the mechanical part. So we are basically just going to allow the fluid to flow through the model without any mechanical stepping. So at this point, we are actually going to generate that pore pressure distribution. And I'll be honest, I'm not the most proficient in our fluid logic. For me personally, it is the hardest thing to understand in all our codes, is the fluid part. And it's still taking me a long time to read through all the documentation and get my head around it. So like, no matter what mechanism you're using, mechanical, thermal, or fluid, you have to have a constitutive model. Right now we're using isotropic, which in 99% of the cases we would use anyway. Line 29 here, this is where we say, okay, we want just the fluid part to cycle. We do not want the mechanical part to cycle. And then we have to give fluid properties. Fluid modulus, which is not the real modulus of fluid. It's 1000. We use a small number to allow us to use a larger time step. This is not going to have any partial saturation, so saturation remains 1. Fluid tension. And then these other values I actually just took straight from the example. And then lines 37 to 40 are probably see they're very similar to lines 22 and 23. That's because just like with fluid, we have to apply, or just like with mechanical boundary conditions, we have to apply fluid boundary conditions. And you'll notice here that on top 1, which is right here, they don't put this as exactly 0. And in the example I was reading from, they did that so it would remain fully saturated in that zone. All right, then we'll add in these 4 lines. Again, you don't need to have that equal sign. That's just old syntax. A couple of histories. This one's at the toe of the slope, near the toe of the slope on the left-hand side. Yeah, -100. And then a history dead center, and up 10 meters at the core of the dam. And then we'll solve it. And since we're solving, we need some sort of criterion to how long we solve. And we use a ratio flow of 1 e to the -5. Don't ask me why exactly we're using that, but we are. I'm just going to go from, oh, sorry, I probably got you typing and you need to see that. Cool, let me quick run it here. Execute those lines. Okay, so pretty easily now we've cycled with fluid on only. So now we should see a distribution of pore pressure, right? So if we go back to our plot, click on the zone, plot item, and the zone value with a color by contour, there will be a pore pressure in that massive list of things. And sure enough, here's your pore pressure. That's the pore pressure profile. Didn't see any kind of, yeah. The reason the state hasn't changed in the zones is because we haven't cycled mechanically. So basically, all these new pore pressures, which generate new forces in the zones, but since we didn't cycle mechanically, nothing will have changed. Well, nothing will have changed with regard to that. So let's just do that now. That's the last little bit. Really, right now, we could take these pore pressures and carry on with our kind of the point of this talk is using Python to distribute those pore pressures. But for completeness, I just wanted to go through the mechanical part, turning fluid off, turning mechanical on. Oh, see now here, hooray, we turned the fluid modulus to 0. Again, it's better written in the documentation as to why that is. And I won't tend to confuse you anymore about that. Fantastic. So the pore pressure will remain the same since we turned it fluid off. But now we can take a look at, say, let's look at the state, and you can start to see there's a little bit of tensile failure on the outskirts of the dam. Doesn't mean anything's failing, because mostly it's all in the past. A little bit of tension now. Take a look at the displacements. So about 5 centimeters displacement on the, and in fact, that's probably mostly from initializing the stress state, because I don't know if I issued a reset displacement. I think I did up here. Yeah, I did here, which was, yeah, I think most of that displacement is actually from when we initialized the gravitational stresses. So it would have been a good idea maybe at this point to initialize the displacements to 0, and then we could have seen the displacement just from what the fluid was doing to the model. I bet if I look at my plot and look at dam 2, displacement is about 4 centimeters there. And a couple more centimeters of displacement by allowing the fluid to flow through the dam. Okay. All right, so this was kind of the point of this model. This is actually, you know, a uncoupled fluid model, fluid mechanical model. But the motivation for it was I just wanted to create a distribution of pore pressure that we're going to take and then interpolate onto another grid. Now the more interesting, kind of confusing looking part is how do we get that pore pressure data, right? It would be nice, and then my initial thought was that, okay, to make this as easy as pie, I'm just gonna go to my plot, take pore pressure, here it is, right click it, export CSV file. Has been disabled in FLAC2D, or I have I do not know why. I think they did it just because we haven't got to implementing it yet. So I'm like, oh, that's very useful. Now we have to do it the hard way. And this is the hard way. It looks kind of nasty, but we'll go through it. So my goal here is basically this. We just want to end up with a text file of position and pore pressure, right? So what it's going to look like is it's going to have an X column of values, Y column of values, and pore pressure. That's all we need, right? So the first thing I'm going to create using fish and splitting is a list of grid point positions. So basically these two right here. And I'm using the brackets here to signify inline fish. So let's go ahead and execute that line. Didn't get an error, that's encouraging. But a lot of times when I make these lists, I want to look at them to see what I really want to make sure what's in them is what I wanted. So the way you do that is in the console, I'm going to type, I wish for some reason it's not showing. Oh, it will here if you click this to the far right, this little symbol, and make sure fish global symbols are checked, not checked. It'll show you right here that it's it exists, it has value, and it's a list, but it's not going to show you what's in the list. There are multiple ways to show what's in the list, but the way I remember is it's the command, it's fish list content. And I think it's a bracket of the list that we just made, which is called GPPOS. So is that right? Yes. Okay, we got those. Now the next thing we want is the pore pressure. So just in the same, there's a function for grid points called gp.pp, which is retrieves the pore pressure for a grid point. And since we're in the realm of lists, we're gonna supply as an argument the entire list of grid points. So it will return an entire list of pore pressure. Execute that. And it showed up in my fish global symbols, has the same size, that's good. And we can do the same thing. Let's take a look at this list. This one's called GP pore. They made a new list over here to take a look at. Cool. All floating point values. 798 of them. List of position, list of pore pressures. Now this part I didn't even know, the next line, I didn't even know how to do. I had thought it would be much simpler, but turned out it wasn't. Now our only goal is to make one list with our two lists, right? We have a list of vectors, position. We have a list of floats, pore pressure. It would be like a simple command, put those together, and then we're done. There is in Python, and it's called stack, which takes 2 words and you're done, but not in fish. My God. So I apologize for how confusing this is, but it does work. So the main idea here is to create our pore pressure data file with position and pore pressure. You need to use the list.sequence utility, which takes our two lists and kind of smushes them together. It's got to be realized, like with lists, you're either like appending a value, prepending a value. But what we're doing here is we have a list, stick them together. And it gets very confusing here because you would think we could just like, and this is initially what I thought. I said I was going to say list dot sequence Okay, give me some GPP position, right? And then some GP pore. End it like that. And since we're dealing with lists splitting, basically, we always have to use the double colon. This was my initial thought. It was like, oh, yeah, that's right. Like that should definitely work, right? Let's give it a try. Oh, and it did. Data size 798. If this actually does work, I would be. I'm just gonna give up. I'm gonna get rid of my last two lists I made here. Okay, so we've now made one called data. Well, let's take a look at it. Oh, well, that's not right at all. Because if you were to take this data list and write it to a file, it would literally, all it would write is list size 2, list size 2, list size 2, which I'm like, why is it doing that? The reason it's doing that is because what you're supplying here, this first one is a list of vectors, and this one is just a list of floats. And by providing that, it's just going to see, not taking the values, but rather what it is. I wish I had a better explanation and I wish it worked like this, but it certainly doesn't. So let's call it grid point position underscore X. And then it will be grid point position dot X will work. And then let's do for the same for Y. Oh, maybe this will work. It'll be amazing. And then in our data, for our data, we can go GP position underscore X. And then the Y one, GP POS underscore Y. And then pore pressure. Did that. Okay, I'm just gonna go double click back on my save state to get to right here. I'm gonna exit out of this fish list. And I'm just gonna grab all of these, see what we get. I did run it. Yeah, here it goes. It says, okay, you ran these. Let's take a look at what data looks like now. Yeah, and then it just says, now it's list size 3, list size 3. So it would literally, if we were to write it to file, we just get size 3, size 3, size 3. So basically, this is comes down to problem of nested lists. And in fact, when I talked to Dave last night about this, he's like, this comes up a lot, surprisingly, with nested lists. And we need a better way to write this data to a file instead of using this giant list dot sequence of a string list of our list, blah, blah, blah. So I'm just going to get rid of all this, go back to how we were. In fact, I actually could have kept it and just changed this line, but this is the line we're looking at. So it's going to take the list dot sequence is pretty straightforward. It takes a list and a list, sticks them together. But what we needed to do is to, since our lists have nested lists in them, we needed to change those nested lists to strings. And the way you do that is using a string. And since we're doing everything splitting, since the arguments are all lists, that means the functions themselves have to return lists, which is indicated by the colons. Okay, I'm going to go back to, I went back to the save state. I'm going to recreate my two lists, make sure everything is correct. Oh, I'm missing. Oh, this, I don't even know it actually needs an argument. I think you can supply arguments to this particular list function. I'm not going to, but it should work either way. Okay, and it does. Now I got my original list back, position list of vectors, position of, or a pore list of slope values. And now run this line. Data size 798. Let's take a look at it. Close out this old one. On the console, I'm just going to hit the up arrow to get back my last command. Oh. Okay, well now I don't know why it's showing that. Should have showed some numbers. I'm not sure why the data file, like when we list the contents, it's not showing the actual data. So what I'm going to do is I'm going to look at the first line in my data list. And that should show me what I want. That's the position, but why isn't it showing me the pore pressure? 3050. I was thinking for a minute that's 3D. Those were the XYZ components. 3050. And the type is string because I told it to be a string here. All right, so now our data list is complete here, and now we want to write it to a text file. The function to write is called file.all, and there's a lot more than just that when you're writing to any kind of file type. Unfortunately, I don't think fish uses the F1 stuff. Holy cow, it does. Huh. Okay, so I just put my cursor on file.all, and then it will tell you how to use this fish intrinsic to write to text files, JSON files. You can even write to fish files, or you can write to binary files. Basically, whenever you're doing writing to some external file type, text file, data file, whatever, file.all is the guy to use. And in fact, the way I'm doing it is making it comma delimited. And the way I do that is using string.join. So we'll take each line in data, and then it will separate those values by a comma. That's what I'm selecting here. You could put like a space there, then your data will be space delimited. You could put whatever you want, but I'm using a comma to basically make it comma delimited. If you do this, if we run that line, no errors. So let's go to our working directory. You should now have one called, yeah. Oh yeah, there it goes. Now it modified it. I was looking at the date and it was yesterday's. I'm like, why is it not modifying it? Okay, so now you should get pp_data text. Open it up. Oops. And there you have X, Y, pore pressure. The more comfortable you get with writing to text files, you can then add columns and different delimiters, that kind of thing. But I wanted to quick check. I wonder if let's go delete that, because I know there's one called string.usb is dot ESB. Oh yeah. Then it would just take one. Oops. Just one argument. See what that does. It's gonna just show the same thing. Yeah. So there is actually a function that specifically just turns into a CSV. Sorry. When I say CSV, yeah, it's not going to be .csv. I should say it's just using comma delimiters. It basically just did the same thing I had with the string.join. Like that. But this function allows you to choose your delimiter. If you look at what types are supported, bring up the documentation. Did it work out? Oh, no. So the type is the second argument. Currently available file types are save, which is specific to our program, text, which is a general text file, JSON, fish, which I never even used. Oh, it's for legacy format, and then binary. So yeah. All right, cool. So that's perfect. That's kind of a good place to stop for now, because now we all have the pore pressure _ data text file. So this is a pore pressure distribution in text format, and we're going to basically interpolate it onto another grid.